So here's our introduction to improper integrals. Thank goodness we are done with integration techniques. This will not be a new way to evaluate integrals. This will just be a different kind of actual integral itself. You're not going to be learning any new techniques. That is done, and we're in the last section. So what is an improper integral? I always keep these intro videos short, so I just want to give you big picture stuff. An improper integral is when the integral is over an infinite region. So typically with integrals, they're calculating areas. So if I give you the integral from 1 to 2 of 1 over x squared, okay, well, what does 1 over x squared look like? I'll approximate it. It's like 1 over x, but it's just kind of squished down a bunch. I've got from 1 to 2. Here's my graph. And this is the area that I want. So this isn't too bad, and it's a really, really easy integral to do. It's just a power rule. However, what if I don't want this area in blue, but I want this area? Whoops. There we go. What if I want this area? It looks kind of weird. But what if I want everything? At first it sounds kind of ridiculous. The area is infinite. But sometimes it actually isn't. So the way you would write this is you start at 1 and the integral ends at infinity. So we write it from 1 to infinity, 1 over x squared. And the way that you do this is you take a limit and you let the upper bound go to infinity. So I'll do it from 1 to b. I'll write that b in a different color. And let b go to infinity. That limit might have a finite value, which means that this area is not actually infinite area, even though it goes on forever. So how would you evaluate this? Well, you just do the integral with the b in it, and then take the limit. This is the limit as b goes to infinity. How do we do this integral? It's x to the minus 2, which is x to the minus 1 over minus 1. So it's minus 1 over x. Then we do it from 1 to b. Keep the limit. Negative 1 over b minus negative 1 over 1, which is plus 1. And this is a limit that's perfectly fine. If I let b go to infinity, I get 1 over infinity, that's 0, and I get 1. So we're going to talk later about what that actually means, but just big picture, that's what this is all about. Another way that an area could be infinite is with an asymptote. So it does not have to be an infinity here. So the other way that this could happen is a function which has a vertical asymptote. Let's say this asymptote was at 3. And I want to find out this area. It goes all the way up here. So that does not have an infinite bounds, but it is an infinite area. It's an infinite region. So this integral, I don't know what this function is, let's just call it f, is an improper integral. And the way that you would do it is you would do the limit as b goes to 3. And you got to do it from below. B is approaching 3, but the ones that are right before b, because I'm approaching it this way. Let me get another color up here. I'm approaching it this way. So my b is coming from the left. So I have to indicate that from the left of the integral from 0 to b. And then you would just do your FTC and move along with it. So there's your intro to improper integrals. We'll get to some examples.